Problem number 10. Our first step is to figure the class width. To find the class width, you need to figure out the range and divide by the number of classes. Range is high value minus low value. Our high value was 110. Our low value is 54. So our range is 56. You want to divide that by the number of classes that you need. In our case, the problem told us we needed 7 classes. So I'll divide by 7. So you get 8 for a class width. It turns out we need to round that up to 9 for our class width. Now, I don't really like this problem. How are you supposed to know you should round up to class width of 9? The rule is that you always round up. And here's what happened. I tried it without it to see, well, maybe I can just leave it at 8. So I tried it. And the problem was when I did a width of class width of 8, I only got to 109. And I need to get to my high value of 10. So that didn't work. So I figured, oh, yep, I must round up to 9. I will not put a problem like this on your test that comes out with a whole number here. It will always be a decimal, and you will know to round up. So now that we know to use our class width of 9, we need to put in our class limits. Start with your low data value. Now you want a class width of 9. So you take 54 plus 9. 63. That's the start of your next class. And then you just keep adding 9 the whole way down. Then you figure the upper class limit, which is going to be one number less than your next value, so 62. Okay, we know we start this next class with 72, so this one must be 71, and so on. Also, you can just keep adding 9 with these numbers as well. For example, 89 plus 9 will get me to 98. Couple things about the class width. Notice that the difference here is not 9. Some people use that to figure, and that's not correct. The difference here must be 9 for the class width. Then you can fill in your class boundaries. Your class boundaries are just 0.5 below this number for a whole number and 0.5 above this number for a whole number. So we'll have 53.5 to 62.5. I have filled in the rest of the class boundaries. The next step will be to tally your data. Just go through your data values in your book and place a tally mark in the blank where that class limit would be. When you're done tallying, count up the number of tally marks for your frequency. There are 7 data points in the first class, and so on. Your cumulative frequency is a running total. So the first one starts with 7, then you add on the 6, then you add on the 8, then you add on the 4, and so on. A running total. The last one that I don't have a column for, but we'll need for some of our graphs, is the midpoint. XM stands for midpoint. To find the midpoint of the first class, you take the lower limit plus the upper limit and divide by 2. 54 plus 62, enter, divide by 2. You get 58. And so on. These will also be 9 apart since our class width was 9. To set up our frequency distribution, we first need to decide the class limits. To do that, we need to know the class width. So we take our range, which is high minus low. In our case, 857 is the high data value, 140 is the low. Divide that by 8. The book told us to put 8 classes. And we get 89.6, which we will automatically round up to be 90. Our class width is going to be 90. Start with your low value. Our low value was 140. Add 90 to get the lower class limit for the second class. 140 plus 90 is 230, and keep adding 90 all the way down. Figure the upper class limit by taking one less than that number. So it must go to 229 if the next class starts at 230. Then from there, you can keep doing that method, or you can just add 90 all the way down. Once you're finished with your class limits, enter in your class boundaries by going, since they're whole numbers, by going 0.5 below the lower limit to 0.5 above the upper limit. Notice that these two values will be the same. Your class boundaries will overlap. And keep doing your class boundaries all the way down, and then tally where your data fit into your categories. Once you've completed your tallies, find the frequency, how many data values are in each class. Count on my tallies, there are 11 data values in the class that goes from 140 to 229, 5 data values in the second class, and so on. I always count and make sure that I have the same number of data values in my frequencies as I do data values for my problem. Next, I'll figure the cumulative frequency, which is just a running total. So I take 11 plus 5, 16 plus 4, 20 plus 4, and so on. Notice this one will be 28 because I added 0. 30 is the cumulative frequency. That should be the total number of data values I have. So if I count up all my data values, I should have 30. The other one that we will need for one of our graphs is the midpoint. Again, you take the lower class limit plus the upper class limit, 140 plus 229, and divide by 2. It's a decimal, which is okay. You could also do 139.5 plus 229.5 divided by 2. From there, you can do that with either class limit or simply add 90. So I'll finish these. So there we have the midpoints. Now we will build a histogram for our data from number 1 off of the front page. On a histogram, on the x-axis, the horizontal axis, are our class boundaries. On our y-axis, or the vertical axis, will be our frequencies. Our highest frequency is 8, so maybe it would work to number by 2s. If you numbered by something different, that's okay, as long as your frequencies are spread out, not just clumped all together, and as long as you go up by a consistent number. So our first bar graph will go up to 7. Our first class had 7 in it. Our second class contained 6, frequency of 6. And so on. Notice a few things about my graph. The frequencies are on the y-axis. The class boundaries are on the x-axis. A histogram is made of a bar graph where the bars touch or are connected. Number 4. Next up, frequency polygon. Frequency polygons have midpoints on the x-axis and frequencies on the y-axis. You make a dot above the midpoint at each frequency. So 58 has a frequency of 7, the midpoint 67 has a frequency of 6, and so on. Frequency polygons connect to 0 are straight line segments connecting each of our frequencies in order and connecting back down to 0. Some things to remember about frequency polygons. The midpoint is on the x-axis. The frequency is on the y-axis. There's a single dot at each frequency above the midpoint. And don't forget to connect your polygons down to 0 so that it completes a polygon. Last but not least is the ogive graph. I sometimes call it ogive. I think it's supposed to be ogive though. On your x-axis, again, go the boundaries, just like the first graph, just like the histogram. On the y-axis, however, go the frequencies. So my largest frequency here is 30, so I'm going to have to go up to 30. So I'm going to have to number differently. Numbering 2, 4, 6, 8, 10 won't work. How about maybe 10s is too low, 10, 20, 30. How about 5s? 5, 10, 15, 20, 25. Oh, I'll have to draw in a 30. So these, again, are my cumulative frequencies. I want to make sure that I'm going up by a consistent number so that I have an accurate graph. When you start your ogive, you always start the first boundary at 0. You'll put your values in at the end of the class. So, for example, our first one here is 7. So that will go at the upper boundary, 7. Next one, 13, goes at the upper boundary, about 13. I'm kind of guessing here. Again, I'm looking at the cumulative frequency part of my table. Then you connect your ogive with straight line. Pretend these are straight lines. I'm awful at drawing straight line segments. Some things to remember about ogives. First, it's boundaries, class boundaries on the x-axis. Cumulative frequency on the y, not just frequency. So you're going to have to change your numbers on your y-axis that you had in the first two graphs. You'll always start at the lower boundary of the lowest class at 0. Then you plot your cumulative frequency on the upper bound of each class. So for example, this first class had a cumulative frequency of 7. So I plotted that at the upper bound of each class. This class had a cumulative frequency of 13. So I plotted it at the upper bound of the class. Upper bound of each class. And that's the ogive. Number 6, the histogram for number 2 off the front page of your homework. I'm not going to go through as step by step as I did on the first page. Go to the first page of these graphs, numbers 3, 4, and 5, for more detailed instructions. Couple of things to note on a histogram. 1, class boundaries are on the x-axis. 2, frequencies are on the y-axis. 3, it's a bar graph showing the frequencies in each class where your bars touch, are connected. Next is the frequency polygon for number 2 on the front page. Here's the frequency polygon. Note, midpoints on the x-axis, frequencies on the y-axis, frequencies as a dot on top of every midpoint, connected with straight line segments. I figured out how to manipulate my sketchbook program in order to make my straight lines. Ha ha. And the biggest thing that students forget, you need to connect back down to the x-axis at the beginning and the end to complete your polygon. Frequency polygon. Now for the ogive for number 2. Here's your ogive. Things to remember. Class boundaries on x-axis. Cumulative frequency on the y-axis, so you have to change your y-axis from the other two graphs. You start at 0 at the lower boundary of the first class. So the cumulative frequency for the first class was 11. I actually graphed that at the upper boundary of the first class. And so on. Connect with line segments. Notice that unlike the frequency polygon, this one does not connect back down to 0 at the end. This is the ogive. This problem asks us to construct a stem and leaf plot for the data. For the stem and leaf plot, you need to first order your data. This is the longest part for me. I look for the lowest, and I cross them out as I go. Ish, that took forever. Remind me to put a shorter one on the test. A couple of things that I do. I see there's 35 numbers here. When you get done, count up and make sure that you have 35 numbers here. Otherwise, you might have to go back. Also, if you were doing this in real life with a bunch of data, you could use a spreadsheet program like Excel, enter your data in any old order, and then tell your computer to order your data, and it will do that for you. Now that we have our data in order, it's easy to do the stem and leaf plot. For the stem and leaf plot, put a line, and on the left side of the line go your stems, the first digit of each of your data. So, like, let's see, we have 30s, 40s, 50s, all the way up through 90s. So we'll have 30s, 40s, 50s, 60s, 70s, 80s, 90s. Now, let's see, I only have one 30, 38. So I put the 8 of the 38 there. Likewise, I only have 140, just a 1, so I'll put the 1 of the 41 on this side. I have a bunch of 50s. 50, 50, 52, 53, 53, 56, 58, 59. So I'm going to put the 0, 0, 2, 3, 3, 5, 6, 8, 9 here in order with no commas. It's just a visual now. We can see that we've got a 50, another 50, a 52, a 53, a 53, a 56, a 58, and a 59. Now I'll do the 60s. 66, 68, 69, 69. So that's a 6, 8, 9, 9. The 70s. At the end, make sure that you count up to make sure, again, that you have as many data values as you have data values. The usefulness of this graph is that you can quickly visually see where most of your data are located. Stem and leaf plot. In your formula sheet, you will find a formula that tells you how to figure out the percent in a pie chart and how to figure out the degrees in a pie chart. Those formulas are F divided by N times 100 and F divided by N times 360. So what's the F? Frequencies. What's the N? Total number. So to find the total number, you add up all the frequencies. 90. There are 90 total students in this survey. So to find the percent, I'll do 12 divided by 90 times 100. I end up with a decimal. I will round that to 1 decimal place, 13.3%. The others are calculated similarly. I will continue finding the degrees in my pie chart. Frequency divided by N times 360. 48 degrees. Same formula. Your total number of degrees should approximately add up to be 360 degrees, the amount of degrees in a circle. Your total number of percentages should add up to be about 100%. It may be a little off due to rounding. It's sometimes hard to draw these freehand. A lot of times I'll use Excel if I want a nice pie chart. I try to start with the degrees that I know or the percents that I know. For example, let's see, this one right here, that's a little more than 25%. So 25%, that'd be a quarter. So I'll maybe draw it out to here. So that's my sophomores. And then 40%, that's a little less than half. So then half would go to here. So a little less than half. That's my juniors. Then 18.9%, that's about 20%, a little less than a quarter. A quarter would be about right there, so a little less. Again, I'm kind of just freehanding these. They're not going to be as exact as if I were to use a word processing or an Excel or other spreadsheet to make a nicer graph. But there's your approximate pie chart. For example, I put my numbers into Excel, and if I just go under charts and a pie chart, it will make a nice pie chart with me that is more exact with the pie pieces.